Welcome to our today's webinar. My name is Hendrik Wiesner, and I would like to welcome our experts, José Garrido and Eduardo Lima. Let's start with the webinar directly. José, Eduardo, it's your turn.
Thank you so much, Hendrik. So first of all, let us introduce ourselves. My name is José Garrido. I am the team leader of the sales department from BMA Automation. As a background, I am telecommunication engineer, and I have been working by BMA for the last 2 years.
Hi, my name is Eduardo Lima. I am the senior engineer for the product automation department. My department is responsible for the automation of all the centrifuges and also some more related products to the centrifuges. And I'm working at BMA already at 6 years. I started at BMA Brazil, and later I'm coming here to Germany. And I hope you enjoyed today's presentation.
Okay, guys, thank you so much. So please start and tell us a little bit about what is BMA Smart Sequencing.
Okay, thank you, Hendrik. Before we start with this dry definition, what is smart sequencing, let us take a look at the process in a sugar mill. As you see it in the slides, it's a schematic workflow from the completely sugar mill, and we put on top of that our big brother, our control system, which will watching and controlling all the phases of the sugar production. But at the end, when the sugar mill is working properly, we will have some continuous flow of raw material getting in the sugar fabric, and then independent if we are using sugar cane or sugar beet, we will have some diffuser or some extraction term to getting the first juice of our raw material. After that, we have a cleaning process, purification process, and this juice after that cleaning will be evaporated. After the evaporation, we will have some crystallizers, and then we get some sugar crystals. And in the middle of this continuous process, it's some centrifuges at the end of the crystallizers. We have two kinds of centrifuges, as you know. Some continuous centrifuges, which are working all the time processing some intermediate products, and some batch centrifuges, which are producing the end product, the end sugar that we want to sell. So, but it is strange that in a continuous process, we are putting in the middle and in a very important part, some batch centrifuges. And a batch centrifuge will working as a batch, starting, processing, stop, again. And that is important because that is the philosophy of our smart sequencing. We want that the centrifuges, the batch centrifuges, show a continuous process or a very smooth functionality so that we have a continuous process as well in these centrifuges. For that reason, let us take a look a little bit closer around the centrifuges. Because we saw that our batch centrifuges will have direct impact in the step before and the step after that if we have some troubles. So let us define what is happening in our batch centrifuges. We have, as we told already, some crystallizer which are delivering the massacute to our centrifuges. The centrifuges are taking some electric energy from transformers, boilers, and so on. And of course, we have some operators which are giving commands to our centrifuges. The output of our centrifuges, the clean and beautiful sugar, will be transported through screw conveyors to the dryer. And when we have some troubles in the centrifugal station, we will have some troubles in the other parts, in the crystallizers, in the electric power supply, in the conveyors, in the dryer station. And that is exactly where our smart sequencing is working. But let us, Eduardo, define what smart sequencing is.
Thank you, Jose. Good introduction to us. So let's start now. What exactly is the BMA smart sequencing? And we have a really phrase that resumes everything, and it's really important. So I will clarify. BMA smart sequencing is a solution to all issues caused by an uncontrolled operation of multiple batch centrifuges. Okay, one more time. BMA smart sequencing is a solution to all issues caused by the uncontrolled operation of multiple batch centrifuges.
Okay, Eduardo, what do you mean with all these issues?
Thanks. So good question. And let's now say examples of some issues. And the first one is the hardening of sugar inside mixers. Let's take, for example, a customer. He has a 30 meters mixer. And in one tip of the mixer, there's a centrifuge making 25 cycles. And in the other tip of the mixer, there's a centrifuge making 20 cycles per hour. So the sugar which is in this tip of the mixer is getting much more frequently to the getting out of the centrifuges. And because of that, you have a different physical characteristic in the sugar, which is in this point and which is in this point. So because of that, it's really important that all the centrifuges are being used with the same frequency, that we also have the same quality and homogeneous quality inside the mixer. Another example, our mixer is getting empty faster than desired. Why this happens? Sometimes the customers are driving their machines to 25 cycles per hour, 26 cycles per hour, and then after 40 minutes, the mixer is almost empty. And then the customer says, okay, now the sugar is over, I will turn off these and these centrifuges. And after 20 minutes, we have a new vacuum pan, and then the mixer is full again, then you start the centrifuges again. And this is definitely not good, because we want the complete factory working always homogeneously. So we don't want that the mixer is getting empty faster. Another example, we have the increasing of filling time to 2 or more centrifuges charging at the same time. What happens is that the column of the mesocute above the centrifuges are getting less pressure if you have 2 or 3 machines charging at the same time. So we don't want that to happen, and because of this, we need to control that at minimum, 1 machine is starting and filling at the same time. So another example is a different service factor. Yeah, this happens, like I said, imagine one centrifuge running 25 and the other centrifuge running 20. And after one campaign or 2 campaigns, you have one machine that has a lot more wear than the other. And so we don't want this. We want that all the machines have the same maintenance at the end of the campaign. One more example, and one of our favorites, is the overload of belt and screw conveyors. Almost every sugar factory has the sugar conveyors not dimensioned for the operation of all centrifuges discharging at the same time. So this is a really important case that only 1 or 2 at maximum centrifuges should discharge together, so that the screw conveyors are not having problem, or the belt conveyors. Also, the not homogeneous throughput in the sugar dryer. This is another example. Yeah, if we have a lot of sugar going at the same time to the dryer cannot dry it at good quality, and this is definitely making the sugar quality worse. And this is also a lot of money lost. So, and at the end, if the customer has 2 or 3 machines accelerating and braking at the same time, we have a lot of power peaks. And these power peaks can be really expensive. So we will show how we can solve this with our product.
So Jose, could you give us some more information how exactly the BMA smart sequencing is working?
Okay, let's try it. What you are saying right now is the schematic, again, how our new machines, our E-machines are working. We have the local centrifuge in the very close to it. We have a local panel where the user are giving instruction and commands to our machine. The local panel has we have a small box because the architecture is a little bit like a distributed control system. For that reason, we have below the local panel a box getting all the signals and transmitting the signals to the main panel where the controller is living. In the same time, we are giving some information to the frequency converter, and the frequency converter is giving electric energy to our motor in the centrifuge. Where is living our smart sequencing? Our smart sequencing, it's communicating with the main panel, with the controller of this centrifuge, getting all the information, how it's going, how is mine filling time, how is mine breaking time, how is the all the status of the centrifuge is working properly, is not, what is the vibration, everything from one and every machine from our bank. So for that reason, the smart sequencing is on top of our bank centrifuges, of our centrifuge station, getting information and calculating automatically how has to work this bank of centrifuges for the next moment.
It's also really important to say here now that the BMA Smart Sequencing has 3 operating modes. Yeah, it can work independently, really good to solve all the problems, but we have 3 modes that will optimize and solve some problems better than the others. And we can see here we have the production mode, we have the energy mode, and also the transport mode. And in the next slides, we will explain exactly how one mode differs from the other one.
Great. So let's start directly with the production mode.
Exactly. So the production mode, and here everyone can see, is an example of 4 centrifuges having 4 cycles. We can see here the speed of them, and what's happening is that all machines are running here and starting almost at the same time. And this time is, let's say, between 5 to 15 seconds, that this is the time one operator needs to start one machine and go to the next machine. And because of this, we can see that this is a really normal profile of the speeds of the centrifuges. But what the BMA Smart Sequencing is doing is basically adjusting and redistributing these centrifuges and saying at every cycle, saying, okay, now you will start, now machine 2 will start, now machine 4 will start. And he's doing this in a controlled way, in a way that all the speeds are balanced and adequately to solve the problems we discussed before.
Okay. Regarding the benefits of our production mode, we have learned that the production mode of a smart sequencing is working for the production of sugar. So we have a nominal capacity of our bank, and our production mode will be assert you this production. But of course, sometimes the production is not 100% all the time. We need to adjust our production level currently for our needs. And that is pretty easy adjustable through our smart sequencing. As Eduardo told us, we will have the same cycles in all the machines in the bank. And that means that we will have the same wearing in all the machines. Easy to maintain, less costs are other benefits of this point. Of course, if we have some issue in one machine and one machine is falling down, automatically we'll connect and we'll share its status to the smart sequencing, and for the next iteration, this machine will be putting down. Everything automatically. Of course, we will have removing of unnecessary waiting time, and that is one of the questions that we will see in the next slides. And for that reason, I put again the same graphic in this slide. We are reducing the braking energy to help the next centrifuges, which are accelerating, giving some energy. That will mean that we will have a reduction in our current consumption, and in this reason, we will have reduction of as well in the peaks of energy consumption.
Right. So in general, why is BMA Smart Sequencing better than a standard or traditional normal interlocking?
So here we have another example, and I will show again some graphs. Yeah, and we can see that the machines, when they start, the first machine is starting, now the second machine, and later the third machine will also start. But now we have a problem. We can see that the first and the fourth machine are ready to start. And this is one of the big problems of the interlocks. You need to set priorities. So normally here in our example, we have the first machine has the priority to the second to the third, and the third to the fourth. And here we can see exactly the problem is we want the fourth machine to start, but this is not what happens. At the end, what happens is the first machine is starting and the fourth machine is waiting and starting later. And again, you have the third, the second, and the third. And here again, we have the same problem. The first machine is ready and the second machine is also ready, and we don't want this, yeah, because now the first machine has also priority, and at the end you have the first machine making 4 cycles, and then the other machine are still in the second cycle. So, and this happened in just 10 minutes. What is happening in one campaign that takes 6 months? Yeah, you have the first machine operating and having much more cycles and also much more wear than the other machines. And the smart sequencing exactly working and avoiding this. So he will take the first machine, says, first machine, you need to wait a little. Fourth machine, it's your time, you will start. And this kind of control is made after every cycle of centrifuges. The smart sequencing is taking all the data from the other centrifuges and taking the decision who should start.
Okay, as summarizing, let us perform a small comparison between the standard interlock schemes all our customers are having and our smart sequencing. If we are thinking a little bit about the intelligent sequencing of the centrifuge, so as Eduardo told us, it is pretty difficult to programming all these characteristics, all these features in an interlock system. Possible it is, absolutely, if your interlock is living in the DCS system, but pretty complicated. The smart sequencing, as we saw, and at the moment we are only with the first operation mode, it's already programming and it's working properly. The wiring effort. If we are talking about from the standard hardwire interlock, all the signals from one system, from one machine to the another, will be wired, hardwired, transmitted to the next centrifuge. That means that we have a wiring effort very complicated, very difficult to maintain, and with a lot of problems. Smart sequencing, as we saw, has a very straight architecture. We are using industrial Ethernet as interface, so only with one cable we are transmitting all the information from the control of the machines to our PLC in smart sequencing. Flexibility. If we are talking, for example, or thinking in swings machines, those machines which are changing the products, which are producing or producing 2 kinds of products, and we will change from one bank, for example, R1 to the other, to the R2, it's pretty complicated to do that in interlock. We need 2 different kinds of wiring. We need some relays to change the signals, very complicated. With the smart sequencing, it's only one tap in our screen and it's already done. And the last point in this brief comparison will be the parametrization of the interlock scheme. My experience says that normally the automation engineers come in once to the station, centrifuge station, and making one parametrization once in the whole campaign, but with our smart sequencing can be made very fast.
So you talked before that about the production mode. So also, of course, we are interested in the energy mode.
So the energy mode, which is one of my favorite, it's again showing some graphs. Yeah, this is really important as I am an engineer. So we have here the speed and the power graphs, and we can see together What is happening is the first machines are again starting, and we see that all the machines have starting to have peaks in the power. And at the end in the transformator and the turbine, you will have the sum of all these peaks. Yeah, and we can see it here. So one machine that has around 130 kilowatts, it's a really small machine. Then going here to, when you have 4 machines, this is going to a peak of 400 kilowatts, and between also minus 400. So this results in a really huge peak. And what's happening when we have the BMA smart sequencing? The BMA smart sequencing will again balance this and make one centrifuge starting and accelerating after the other. And at the end, what you see in the power grid is that the powers are much smaller and the peaks are definitely almost nothing compared to what was before. So we can see again, and both graphs in the same size, same scale, the difference between the power. And this is really important today when we want to have a more energy-friendly factories that we are using this kind of solutions. So what is exactly the energy mode? So in energy mode, the BMA smart sequencing will calculate the best way to minimize power and energy peaks. This is really a little different from what we have in the production mode, because the production mode is trying to have you the adjustable throughput or the maximum throughput if this is desired. The energy mode will say, okay, I will maybe not give you the maximum, but I will minimize your peaks. So this is an alternative solution.
Okay, and now it's coming again, Jose, to explain what are the benefits of this working mode. The benefits is, of course, Eduardo has defined already, we will have a big reduction in current fluctuation between the machines, and that leads to a smaller power and energy peaks. And that means saving money, because if we have less energy consumption peaks, we will have a smaller energy bill. And not only that, if you are co-generating, if you are producing energy, selling energy as alternative product, this energy will be bigger. So you will have a better performance and a better efficiency in your cogeneration. Of course, we will have a smoother operation in the turbines. The turbines are the elements which are generating the electricity, and we will have, of course, less maintenance because of this smoother operation. The reduction from around 50% of these peaks will be depending of the centrifuges and the topology of your station. We have to say it. And at the last of the benefits that we have in this energy mode from smart sequencing will be the smaller electric equipment, for example, transformers, the cables, and so on.
All right. So now we mentioned the first 2 modes. So of course, I think we are all interested in the last mode, in the transportation mode.
Yeah. So what exactly is the transport mode then? Yeah, we have here an example, and we can see the 2 machines are discharging at the same time. This is really possible at the transport mode, because the transport mode, he wants and take the consideration the time the sugar will be in the conveyor, and then calculate the best moment to discharge the centrifuges. So what is important here is to not let the conveyor be full or the sugar dryer to be without sugar and after 2-3 minutes with a lot of sugar. So here we may have 2 machines discharging at the same time, but they need to be one at this side of the conveyor and the other at this side of the conveyor. We don't want 2 machines, one near the other, discharging at the same time, because this will result in an overload. So here the main focus is really to minimize problems in the conveyor.
And what are the benefits? So forget the broken parts in your conveyor, the overload on the conveyors, getting sugar from the ground. That won't happen anymore. Of course, because we are given a smooth flow of sugar to the dryer, we will have a constant and higher quality in our end product, in our sugar. But we have an interesting example of this transport mode, isn't it, Eduardo?
Yes, exactly. So we had one customer and they are having these kind of problems which are really common. And we can see here a real measured data. So this was taken from this customer. And we can see here, he had a normal interlocking system. And what is happening is the first machine discharging, second machine, third, fourth, and fifth machine discharging almost at the same time. And we can see here the load of the conveyor is going from 0 to 100%. And we can see what happened is, okay, the load was okay, but after having all these machines discharging, the load was going to 100%. Then the customer, he had a safety system and was turning off the conveyor. After some seconds, the customer tried again to start the conveyor, but the conveyor was still full. So it was necessary, so the safety system again made the conveyor turn it off. And to solve this problem, then the customer needs to wash the conveyor, and then you are losing all the sugar or you are losing money. And again, this is not what we want. And after installing and configuring the BMA Smart Sequencing, we could see that now all the machines, they are still discharging a little near the others, but in a different way. And we can see here the load of the conveyor. Sometimes we still have peaks, but they are okay. They are between 20 and 70% of the load of the conveyor. And by doing it, the conveyor was never more overloaded. So this is a really good application that worked for our customer. So.
All right, so the next topic then, which issues BMA Smart Sequencing could really solve?
Okay, so we have saw at the beginning a lot of issues that our batch centrifuge can provoke in this continuous sugar processing. We have saw that our smart sequencing are able to resolve all of these problems, all of these issues, but of course we have to take some kind of compromise, right? And for that reason, we have prepared this small matrix to show the very first issues that we comment and what are the working mode of our smart sequencing, which are giving you the result from this problem. We started with the upstream issues, that means with our power supply and with our crystallizers, and we talk at the beginning about the hardening of sugar inside the mixers. The best way this problem to be resolved is using our production mode, but as well with the energy mode, we will have a big improvement of this issue. The second point were these mixers getting empty faster than desired, and again, that will be made through our production mode. The production mode, I repeat, it was made to produce all our sugar, so we want adjusting to the real needs of the fabric. And about the power peaks and energy peaks, of course, the energy mode was made for this maximization of this problem.
So, and then we have also the downstream issues, the issues that were happening because of the machines after the centrifuges or even the centrifuges itself. So we have here the example, the first one is the increase of filling time to do centrifuges charging at the same time. Yeah, we said that this could happen, and the production mode will really solve this by balancing the moment that every centrifuge will start to filling. The energy mode can also solve this, but not in an optimal way. We have the case that the different service factor for the centrifuges. Yeah, one machine is making too much cycles and the other not so much. For this, every mode will work equal, and every mode will warrant that every machine is doing the same quantity of cycles. So, and at the end, we have the problem in the transport and the overload of belt or screw conveyors and not homogeneous throughput in the sugar dry. Both production and energy mode, they could help to support this, but definitely the transport mode was developed only to solve these kind of issues. So definitely transport mode would be the best one.
All right then, I think Jose, the benefits, it's your turn again. So would you like to summarize the presentation for us?
Absolutely, thank you, Hendrik. So let us take all together what we have talked in the last minutes, giving you the benefits at a glance of this amazing product, which is smart sequencing. You saw that we have a solution for all the issues that you can have in our centrifuge station, independent of the working mode. We talk at the end, when we install the system, we have to find a compromise to resolve all of them, given some compromise with another issues. We have inside this product 3 working modes to optimize the throughput, to reduce the energy peaks, and to improve the sugar flow to the conveyor and to the dryer. The solution that we have presented to you, it's not only available, or it doesn't work only for BMA machines, it can be applied for other centrifuges from other suppliers. No more overload in the conveyor, no more issues in the dryer, no such a high energy peaks consumption, no more unnecessary waiting time. All of these benefits will be have if you are getting this smart sequencing, and of course the smart adaptation to the problems that can happen. And for the moment, that was everything. Thank you so much for your attention, and we look forward to answer all your questions. Thank you.
Okay, also from my side, the two of you, thank you so much for this awesome presentation. And I think we should directly start into the question and answer direction. I would like to start with the first question. So someone asked, you've shown only BMA centrifuges and mentioned now on the last page that also other machines are possible. Do we have any limitations, or can we really implement every brand of every type and every model?
Of course, the BMA machines would be the best, because we have also the access to our PLC software program. Mm-hmm. So we can go there and communicate the parameters we want to change, and this makes everything easier. But with all the machines from other suppliers, we can also receive some signals as digital inputs or analog inputs, and we send as digital outputs and analog outputs, and we can also communicate with them. But we need also that the customer is sending the necessary signals to us, but definitely it's possible.
Okay. So the next one, it's likely linked to that one. Different machine sizes, for example, B1300 or B2200, what would happen if we do the smart sequencing for that?
Okay, so what happens is when we have different machines with a big different cycles, we can configure all of them as the same station, but we could also configure them in different stations. So we could, let's say the customer has 5 B2200 and 5 Bs 1300. Yeah, so we can configure these 5 in one station that they are working in a similar way, and the other Bs in other station that are also working in a similar way. Because of course, if you have one machine working really different from the others, you need at the end to balance this, and you may lose some cycles, and this is not what we want. So with in case machines different, we are configuring them in different stations.
All right.
At the end of the day, when we are installing, we are making a key solution for the customer. They could have a lot of issues, and we have to look exactly what are those issues, what are the most important issues to be resolved, and then we program, or the guys from Eduardo will program and make the key solution perfectly adapt to your needs.
Great, thank you. So, is there an impact if you have older or new machines or bigger and smaller drives?
Not really. It's for us, it's the same. As we said, if the machines are really different from the others of it, the time for the cycles are really different, then we are adapting them in different stations. So, but for us, there is no difference.
Right. So the next one is, do you have any kind of simulation or calculation tool, as you have shown real figures already in your presentation?
Yes, we have then. Can show here some what we have. So I will show here we have our app, because this is what was really coming from a lot of customers. Yeah. So a lot of them would like to know exactly how much energy we are having, how are the peaks before, how are the peaks after. And it was really important for us also to better understand this and to develop a tool where we could calculate this. So here we can say the type of the motor, who is the manufacturer, also the type of the machines, and say here again if it's 210 or 250, if it's the E2240, for example. And by doing so, we can also configure here different stations, and we can say the number of machines, and we go into the graphs. And by here, we could really see how are the difference before and after the sequencing. Here, I will put, for example, how is the total power. Yeah, this is with sequencing, and this is without sequencing. So again, without sequencing, and this is with sequencing in blue. So we can see, we can estimate here and making some simulations for the customers. And let me give here a small zoom. So, yeah. So here we see exactly the difference. So when the customer has all machines charging, he has really big peaks. But here, when we are doing with sequencing, then the peaks are much smaller. Here we can see that the reduction was maybe minimum 50%. So this tool is also helping us to provide its customers some reports telling what we can calculate. Of course, this is only simulations, and sometimes this is not 100% the same as what we have in the sugar factors, but this is really helping us and our customers to calculate better the improvements.
So Eduardo, this tool will be prepared during the quotation phase or after the order was placed?
We can make it in the quotation phase, no problem at all. We have this app, we can make it really fast, and we are doing this to not delay our quotation. So at the quotation phase, if the customer is really interested in the energy solution, we can really make it.
Great. All right. The next one. Is it possible to calculate an ROI for such system? Somebody, or we are interested in more commercial details.
So to calculate exactly the return of investment is not so easy, because, for example, if we are talking about the reduction of energy peaks, energy consumption, it's depending of the land of the country, how big your energy bill is. So for us, we can make some studies of that, but of course it's difficult because from one country to the another, it's pretty different. But of course, we can make such a study for you.
What is important here is it's possible, but BMA alone cannot do that. Yeah, because we need also information from the customer. We need to know, for example, if the problem is in the transport, the belts are getting broken every 2 weeks. We need to know how much time the customer delays to change the part that is broken. With this, we can calculate a return of investment, but of course, we need a little help from the customer.
So the next one is, which mode would you recommend in general for a cane sugar factory?
So it's not much about cane or beet, because the smart sequencing is made for both factories without difference. What we would like is to know which kind of problems the customer has. If he has problems with transport mode, so we are using the transport. But if this customer has problems with the peaks, we are using the energy. Or if the customer have problems that the mixers are not working well, so probably the energy mode would be the best one.
So what you mean is also after the installation, you can change the mode directly on site by the customer himself?
Yes, at the commissioning, and also after the commissioning, the customer can configure it at the mode he wants and what is more suitable for this time of the year.
Okay, perfect. You just mentioned cane and beet sugar factories, and I guess, of course, as well for sugar refineries, the system is working the same. Okay, great. So I think these are the questions for today. We already have filled a lot of the time. So once again, thank you guys so much for having you here. Lastly, let me also announce the next webinar. This one will take place on the 6th of August by our expert for the Smart for Sugar, Christine Oderfer. The topic will be smart monitoring, hands-on. And you can also register for that on our website. And for the time being, we thank you so much, all of you viewers. And please stay safe and take care, and see you the next time.